Welcome back to the video series of statistics in machine learning. In this video, we are going to talk about bagging. It will be in contextual decision tree. So let's talk about what it is. It is one of the ensemble method, and in all ensemble method, we bring multiple models together, not necessarily of the same type, but they contribute together to the final outcome. Why ensemble methods are popular is because they bring down the variance. And since we are combining multiple architectures together, they are less interpretable, but they are highly flexible, and they can be used for both types of problem of classification and regression. And obviously, since they are bringing down the variance, they offer high accuracy. So now discuss what bagging is all about. They exist because of bias variance trade-off, and bagging helps us reducing the variance without affecting the bias significantly. And how it works is that we generate m different bags consisting of n randomly sampled training instances, and these m bags are used to train m different models. How this helps is that every M model is different from each other and provides a better step for getting the right output. Now, if you're using bagging, then our selection of training is random selection with replacement. Depending on selection and replacement policy, the name is decided. So be careful to name your ensemble method clearly. So bagging can be used for regression and classification. When we're using it for regression, we get mean of all the results from the M trees. And when we perform classification, we perform voting, soft or hard, to find the output class. Interestingly, bagging helps us in doing away the concept of pruning, which may lead to loss of information. Bagging mitigates the overfitting since we make a large number of trees and our results are not affected by overfitting due to mean or voting process. They are less interpretable since we brought large number of trees together. And finally, we have a look at how they did via performance index of Gini or residual sum of squares. See how simple bagging is. Just train a bunch of decision trees on a subset of training example, chosen with random selection and replacement, and then we are good to go. That is from this video. Hope you liked it. Do connect with me on LinkedIn for any doubts. My link is down below. Thanks.